Inside the shadow of Geneva, under the world's floor, lies a shock of human inventiveness and a normal harbinger of destruction. The Beast Hadron Collider. It is a manual of keen evaluation, permitting analysts to examine the subatomic generally and prompting the disclosure of the baffling God particle. A statement made recently by the famous physicist Brian Cox sent waves of wonder throughout the religious community. Something significant has been examined at CERN, something that might have consequences beyond our comprehension. Has our fundamental objective for educational advancement placed us on a collision course with disaster? As we jump into the pit of this clear problem, we must first understand what substantial particle gas pedals the enormous Large Hadron Collider, LHC. Operated by CERN, it is a 17-mile ring of superconducting magnets and the world's most powerful and sophisticated atom smasher. It represents the peak of human scientific achievement. The truth of the situation is solid enough that it can investigate the actual conditions of the universe's creation. But should this design desire to open the insider assessments of the universe, we must be cautious of the way to something clearly more visible and upsetting. CERN, established in 1954, is one of the world's most important and renowned research institutions, collaborating with 23 member states and a vast network of specialists. The LHC is CERN's central endeavor. However, it is only one piece of a larger network of particle accelerators and detectors. This race is not for engines or horses. It's for subatomic particles, and it's a race towards existence itself. The LHC accelerates protons to nearly the speed of light, sending them on a missive course that replicates the energy of the universe at the time of the Big Bang. The effects create temperatures 1 million times hotter than the core of the Sun. A massive array of magnets directs the protons on their journey, while stunning cooling systems maintain the magnets at temperatures colder than space. These contain 1,232 dipole magnets, which guide the beams, and 392 quadrupole magnets, which focus the beams just before collision. Another prominent kind of magnet is used to compress the particles together to increase the chances of collisions. The task of CERN is to collide two needles 6 miles apart with such precision that they meet. The accuracy required is astonishing. The advancement is unparalleled. The LHC's design is a marvel of engineering. It incorporates extensive underground support systems safeguarded from radiation fields. The entire beam system is cooled to a temperature of -456 degrees Fahrenheit, colder than the vacuum of space itself. This cool environment is essential for the superconducting magnets to function optimally. The LHC operates in 4 regions across the accelerator ring, corresponding to the locations of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each serves a unique purpose in studying the fundamental components of particle physics. Collectively, they capture remarkably detailed images of the collisions. Researchers then sift through the debris, searching for signs of the elusive Higgs boson, dubbed the God particle, an extraordinary key to understanding the universe's fundamental structure. It's like examining a boundless jigsaw puzzle, one in which the pieces are dark, and the picture is challenging to grasp. By focusing on the microcosm, we gain insights into the universe, but with each answer comes another question, and with each discovery comes another challenge. The LHC isn't merely a scientific instrument. It is a symbol of human curiosity, progress, and exploration. It embodies our chosen journey for knowledge and our desire to understand the fundamental forces that shape our universe. Yet, as we stretch the boundaries of what we understand, we must also contemplate the moral and existential questions that arise. What are the risks of exploring the unseen world? Should our quest for supremacy suddenly unleash forces we have no control over? Within the hallowed halls of CERN, where the limits of human understanding are constantly pushed, a revelation has emerged that sends a chill down the spine of even the most composed scientists. Brian Cox, a former researcher at CERN and a voice of authority in the realm of particle physics, recently made a statement that has left the community both captivated and stunned. Cox's remarks reverberate with a dreadful possibility. The aim of CERN's Giant Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right. A smaller version of the very event that birthed our universe. The physicist also suggested the implications of this goal, highlighting the LHC's incredible potential for unveiling new realities. This includes its capability to uncover the mysteries of dark matter, a substance that comprises a significant portion of the universe. Consider the allure of approaching the very essence of the universe. It is an enticing opportunity, yet one fraught with danger. The mini-Big Bang is not without its questions, a theoretical concept within the LHC. The temperatures, the pressures, the extreme energy levels replicate the conditions of the universe's dawn. It's akin to standing on the earliest moments of written history, witnessing the dawn of existence itself. However, with such power comes immense responsibility, and the questions of potential risks loom large. Think about what could happen if something were to go awry. Back in 1978, Russian physicist Anatoly Borsky experienced an incident that could have cost him his life. While working on the U.S. synchrotron at the Alliance for High-Energy Physics in Russia, a malfunction caused his head to inadvertently enter the path of a proton beam. The beam, which had the power to destroy matter, passed through his skull, entering at the back of his head and exiting through his nose. Borsky's experience was extraordinary. He reported a flash more brilliant than 1,000 suns, yet he suffered no immediate effects. The properties of the beam caused significant destruction, consuming tissue and bone. Remarkably, he remained conscious and even walked to the hospital for treatment. The aftermath was both horrific and fascinating. The beam caused localized tissue death, leading to hearing loss in one ear and partial facial paralysis. Yet, Borsky's cognitive abilities remained intact, and he continued his research work. This incident is not merely a personal tragedy, but a cautionary tale that underscores the vast power and potential dangers of particle accelerators. The risks associated with a particle accelerator like the LHC are not trivial. That TOB played with the cutoff for astonishing reactions, the valid surface of truth being controlled. These are not the stuff of science fiction. However, as an elective guaranteed pressure is voiced by remembering a couple for the instructive close by locale, the universe's special bits of knowledge are principal toys as well as units of fundamental energy. Potentially, the best horrendous and satisfying tensions related to the LHC's tests are the credibility of making a more unobtrusive than anticipated faint void. Weak openings are neighborhood people of spacetime, in which gravity is so consistent that not even light can sit around close to their interminable vacuum cleaners, the devourers of stars, the secretive parts that cover in the shadows of our universe. The possibility that the LHC could create this of substance, even on a bid development, is a decision for the standard egalitarians and specialists. The same should apply should this dull opening create wildly, swallowing the Earth from inside. In any case, specialists at CERN have ensured that any dull void made would be small and evaporate rapidly. The distant bet has lit conversations, fears, and an energy of awe at the power we involve. Understanding how the LHC is essential to making a faint opening involves the fundamental mechanics of molecule fuel petals, while protons are squashed on the opening at, for all intents and purposes, the speed of light. The power is stunning to the variable that it turns the external layer of spacetime itself. Contemplate a trampoline, broad and tight, and afterward a gigantically dropped weight onto it. The surface turns. It's also vital to recognize the store palatable. It could create a void so colossal that anything nearby would be added into it. That is a silly portrayal for what could have to emerge in the LHC in the space of quantum science, where the thoughts of the universe are both odd and mind-boggling. There exists a theory that more basic components are presumably stowed away inside our reality. If these parts exist, the LHC's experiments could indeed make use of them, creating a gravitational line that weaves to some degree into a dull opening. This disheartening dance of flume, and some has indeed even gotten the notice of a few exceptionally popular specialists, including the late Stephen Hawking. In his book, he forewarned of a situation wherein the Higgs boson could become unstable at extraordinarily absurd energy levels. This irregularity could likely cause an overwhelming vacuum, a catastrophic event that wouldn't simply destroy the Earth, but the entire universe itself. Sir Martin Rees, the English cosmologist and astrophysicist, allowed his own side interests to be known. He assessed the assessments driven at CERN in his mechanized book on what's to come, Opening Doorways for Humanity. He analyzed the potential dangers connected with molecule smasher assessments, which combined those at CERN. His words were not simply a safety measure. They have been reached with an energy of existential pressure. He alluded to the most frantic outcome conceivable, where a hopeless evaluation should create a situation known as vacuum feebleness. This precariousness could theoretically trigger a degree of progress that would resound through the certified surface of spacetime, resulting in catastrophic outcomes that would devastate the total universe. Ries's inclinations were not confined to theoretical experiences. He seriously an open door to those astonishing impacts. At any rate, a low one. In any case, a little probability should give us cause to pause and think. The stakes are immeasurably high, and the edge for mishandle is razor-thin. The specialists at CERN have considered the expected risks associated with their tests mindfully. They have done different security conventions and reasonable measures to mitigate any potential wagers. At any rate, the chance of scientific assessment intrinsically consolidates some level of weakness, particularly while plunging into new districts. The quest for knowledge has forever been accompanied by a level of risk, assuming control over the entire cycle of all that working out. Predictable leap progresses have routinely been accompanied by startling outcomes. However, it is precisely this ability to stretch limits that has prompted humanity forward. The LHC represents the perfection of numerous significant stretches of reasonable progression and typifies humanity's voracious curiosity in the universe. Anyway, the normal dangers faced by tests at the LHC can't be dismissed. While the probability of horrible occasions might be low, the results could be critical. Thus, it is essential for experts, policymakers, and the general public to engage in open discourse about the moral and thriving repercussions of such examination. Bringing everything into account, the Hadron Collider at CERN is a miraculous feat of human ingenuity and intellectual accomplishment. It offers remarkable insights into the fundamental nature of the universe. However, with incomprehensible power comes astonishing responsibility, and it is crucial to approach this essential evaluation with cautious reflection. As we continue to unlock the privileged insights of the universe, we must remain vigilant and aware of the potential dangers involved, ensuring that our quest for knowledge does not compromise our security and well-being. The Hadron Collider at CERN stands as a testament to humanity's relentless mission for understanding and exploration of the universe. Its immense size and intricacy embody the pinnacle of scientific progress and international collaboration. However, beneath its impressive exterior lies a realm of profound ethical questions and potential implications. The Collider's primary objective of unveiling the hidden aspects of atomic physics has led to significant breakthroughs, including the precarious Higgs boson. Nevertheless, the extraordinary energies generated within its sections also raise concerns about potentially harmful outcomes of such endeavors. While robust safety measures are in place to mitigate risks, the possibility of catastrophic events, like the formation of miniature black holes or other unforeseen anomalies, cannot be entirely discounted. As experts push the boundaries of our understanding, it is essential that they do so with a profound awareness of specific assumptions and transparency, engaging in open dialogue with the public and policymakers. As we delve deeper into the complexities of the Hadron Collider at CERN and the scientific inquiries it addresses, it becomes increasingly clear that the mission for knowledge is not without its risks and uncertainties. The Hadron Collider, with its extraordinary capabilities and potential for momentous discoveries, remains a testament to human ingenuity and the ongoing quest for understanding the fundamental laws of the universe. However, beneath its captivating facade lies a realm of significant ethical considerations laden with possible dangers. The investigations conducted within the confines of the Collider harness energies and forces that are beyond the comprehension of most laypeople. The impact of subatomic particles at nearly the speed of light generates conditions akin to those that existed in the earliest moments of the universe, allowing scientists to probe the foundational building blocks of matter and explore the very fabric of spacetime itself. Yet the immense energies associated with these experiments also pose substantial risks, both known and unknown. Arguably, one of the most pressing concerns regarding the operation of the Hadron Collider is the anticipated creation of transient black holes or other peculiarities that could have unforeseen consequences. Although theoretical calculations suggest that any such black holes would be temporary and pose no threat to Earth or its inhabitants, the prospect of inadvertently unleashing forces beyond our control remains disquieting. Moreover, the sheer scale and complexity of the experiments conducted at the collider necessitate stringent safety protocols and rigorous oversight to mitigate any potential risks. The collective community of scientists and researchers engaged with the collider's operations is acutely aware of the imperative to prioritize safety and ensure that all experiments are conducted with the utmost degree of caution and responsibility.